Hello and welcome to MIS 4320. I'm Dr. Payne, and unfortunately we weren't able to have class today, so I thought I would record a video to give you some of the introductory information so that we can hopefully get things going on Thursday. So our course hub, as you can see right here, is on Blackboard, and if there's something that comes up that isn't on the syllabus, or if you need a reminder, I will put it in the announcements right here. So, first thing to know is that I post my own slides that I make under course content. So those generally pop up about half an hour before class. So the slides from today's class are right here, Class 1 Introduction and Software Guide. So I highly recommend that you download the slides, because that's what I'll be using in class, and they're a pretty good reference for the exams as well. So, as I said, welcome. This class is labeled as Android, and because of some curriculum changes, what we're going to do is we're going to study Python. So, why Python? I'll talk a little bit about this in a little while, but Python is a really versatile language. It's not one that's often covered in class, so it's not one that's often taught at a university. So because I was kind of given this opportunity to have a little bit of my own input into what the students would study, I thought that Python would be a good idea. It's very human friendly and you can do so much with it. So welcome again. To get you started off on the right foot, so we weren't able to do introductions in class. I know a lot of you were in my Java class last semester, so I hope you had a really nice break and are fresh and ready to come back. For 5 points extra credit, go ahead and send me an email at kcpayne@uiwtx.edu. If you do this before class on Thursday, on the 18th, then yeah, I'll give you the 5 points extra credit. So something along the lines of, hi Dr. Payne, what your name is and your major, and then a little bit about why you're interested in the class and anything else that you think I might be interested in knowing about you. So again, I'm Dr. Payne. I'm from the south side of Chicago originally, and I did my undergraduate at Illinois Wesleyan University in Bloomington, Normal, Illinois. It's right next to ISU. Then I did my PhD in Management Information Systems at the University of Arizona with my advisor Moshe Dror. We did a project on build a system for bicyclists, basically, to minimize perceived exertion on long distance tours. So I have also I have 2 CS minors, so I have some technical background and some kind of more behavioral background as well. I have 2 dogs, and my husband also, he programs and he has a master's in information systems as well. So that's a little bit about me. Again, send me the email. I'll give you a little bit of extra credit to start. So our course, we are very lucky. We're meeting in Gorman Building 118. They give us the lab. So what this means is that everything that you need is going to be installed on those computers. And if you want to install on your own machine, I highly recommend it though. And I will post a link for a different video to show you how to do that. So we're going to be Tuesday and Thursday, 10:30 to 11:45. It's right before lunch. I will be in my office for free office hours Monday, Wednesday from 9 to 10 after my 7:30 class, and then Tuesday, Thursday from 3 to 4, so right before class. So these are times that I'll just be there. You don't need to make an appointment. Just come see me if you want help with a programming assignment, or if you have a concern about anything. My door is not usually that open, and sometimes I leave the lights off because I don't like the fluorescent light, but I should be in there. Just come see me and we'll get whatever it is that you need worked out. If those times don't work for you, send me an email at kcpayne@uiwtx.edu and we can set up an appointment for a different time. So I'm not going to go into detail on the technology here. I'll leave that in a different video. But basically, we're going to be using Eclipse. Eclipse is a development environment that typically is used for Java, but can also be used for Python. I chose it because it's perfectly fine. It's free, which is the main thing. And I guess it used to have issues in the past, but I really haven't had any problems with it. I think it's pretty easy to use, and it's what's installed on the machines in 118. So you'll have to, if you took Java with me last semester, you won't have to do what's on this slide, but you'll have to do this step here. If you don't have any of this and you want to use Eclipse, then you'll have to go through all these steps, and there's a separate video for that. That being said, if you want to work on your projects in a different IDE, that's perfectly fine. I just won't be supporting it in class, so this is what I'll be using in class. Okay, so I will give the link for that on Blackboard. So if you ever need a link for anything or anything like that, it's always going to be on Blackboard. And another little incentive to get you started off on the right foot, an additional 5 points if you can show me that you have the technology on your own computer by next week, Thursday, so the 25th. So not required, but is highly encouraged, and I wanted to incentivize that because as soon as you get it on, our programming assignments are going to come up really fast, and you don't always want to have to rely on the school computers to get them done. All right. So the other materials you'll need are the textbook. So we're going to be using, it's a pretty nice textbook, Automate the Boring Stuff with Python. And you can get it from Amazon here. Let me see if the link will actually open. So Automate the Boring Stuff with Python. You can get a paperback of it. You can get an e-textbook. Now, highly encouraged. What I will say is that you can also get the information that you need from this link. It is available. It'll open. I'll have to trim that already. It's okay. It's taking forever. Okay, so it is also available here. They do have it on the website here. So, for example, for Tuesday's class today, we have Chapter 0, the introduction. That's what we're going through today. And then for Thursday, we'll be working through some of the Chapter 1, the Python basics. So this is all available on the syllabus. All right, so that's going to be our textbook. Pretty reasonable in terms of price. All right, so let's take a minute to go over the syllabus. So on Blackboard, it's available under the syllabus. Occasionally I update it if something does change, but let's open it up right now. Okay, so let's go ahead and open up the syllabus. I did just update the link. I'm not really sure why it wasn't correct, but here we are. All right, so textbook, Automate the Boring Stuff with Python. We're meeting Tuesday, Thursday, 10:30 to 11:45. You have my office hours here. Again, Monday, Wednesday, 9 to 10. Tuesday, Thursday, 3 to 4. If you want to find me, I'm in the Agnes E. Sosa garage on the 7th floor. use the left-hand elevator to get up there, and then come to room 112. Or you can email me at any time, kcpayne@uiwtx.edu. What I'll say about email is I try to get back in 24 hours. It's especially helpful if you have a programming question to send a screenshot. So I can just look at the screenshot and say, you know, have you tried this? If you don't have time to come in. All right, so first of all, what are we doing? What's the objective of the course? So data analytics is huge. I mean, and it's just going to get bigger. So basically the idea that there's so much information available, and it's the people that know how to process that information, how to make sense of it, and how to make recommendations and make good decisions based on that information. Those are the people that are going to be the most successful kind of coming out. You know, you're flooded with information all the time. Something as simple as deciding, you know, what kind of a used car you're going to get. You can't go through all the information that's there. You've got to have a way to process it. So Python is a language that is used very often for doing this kind of processing. So what we're going to do is we're going to go through some basic programming concepts. We're going to spend a lot of time on that because, well, if you know how to do that, then you can do the harder stuff. So if you've had a programming course before, whether it's from the CS department in C++ or with me in Java, a lot of this will be very familiar, but I don't think it hurts to have it again. So really, if you're looking to get, let me say this, if you've already taken a programming course and you feel like you're an expert, this might be a little too easy for you. However, if you're looking to kind of build off of where you've come from and then go into some application, I think it's a good fit. So I just want to preface by saying that. So yeah, if you're looking for kind of, you know, a programming 2 course, this isn't exactly that. It's giving you the Python flavor and the applications at the end while looking at some basic programming concepts at the beginning. So we're going to be using Python 3 and Eclipse with PyDev, and that's all installed. So it should be fun, honestly. I think it'll be a lot of fun. So the schedule should be the way that it is, but if something changes, I'll let you know. If we look at the syllabus, you'll see that we spend multiple days on most topics. So I like to do that just to make sure that you get it. And there's quite a few programming assignments, as you can see. I'm planning on dropping one of them so that only 10 will count. That's the plan. So I will give you information on those. They'll probably be fairly short simply because there's so many of them, but I want to make sure that we hit all the different topics. Looking at the schedule, this class meets at 10:30, so some of the Easter evening holidays don't really apply. So this is what it looks like. We have 2 midterm exams and then a final exam. You can see that it's kind of broken up into modules, so each exam is not cumulative. It's just whatever that chunk is, that's what's from exam to exam. So the first one's on all this stuff, the second one's on all this stuff, and the third one is on all of this stuff. So you can see that the third module is really the one where we start to dig into kind of the more interesting things, reading and writing files, how to use a API in Python, and do a little bit of web scraping. Okay, and then of course we have spring break. And no classes then. I don't intend to assign any homework or anything like that then, so, you know, just try to get your number 7 in before the break starts. That's kind of the plan. Oh, our final exam is Tuesday, May 8th, 10:45 to 12:45. So if you have some kind of conflict that's related to sports or whatever it is, just let me know as soon as you can so that I can kind of make arrangements for that. So please note when the final exam is, and we'll go from there. Okay, next thing, academic integrity I take very seriously. So don't submit another student's work as your own. So if it looks like there's been some funny business, basically both assignments will receive 0 credit. It's pretty simple. Same thing for exams. So, you know, if I see something, I'll just take the exams and that'll be the end of it. So don't do that. I stress it a lot because, well, I really do want people to learn. Like, I really want them to know it themselves. And so you're not going to do that if, you know, you're kind of trying to just use somebody else's work as your own. So, all right, that's all I'll say on that. The next thing, so what I like to do, if you've had class with me before, you've seen this, I give, actually, if you look down here, 15% this time for attendance and participation. So the way this works is it's called the daily dish, and it's kind of cheesy, but that's sort of how I am. At the end of each class, I'll give you a couple minutes to answer some prompts on an online form. So this time it'll be through Microsoft Forms. And I'm not looking for a correct answer. This is what's referred to in the business as a formative assessment. So it allows me to ask you a question, and you tell me what you think the answer is. And then the next class, I can come back and say, well, you know, this is what we need to work on, or this is what it was. These questions can also build into exam questions. So it's really good for everybody. It helps me see where the class is. It helps you know kind of what checkpoints you should be looking at, what was important. So there's going to be 28 opportunities to earn this credit, but you only need 25 for full credit. So there's no extra credit on this. It's just that there's more points offered than you need. So your excused absences are built in. Okay, so you get out of this 28 minus 25, really 3 excused absences. So you just won't get the credit for that day, but you can still get full credit. So you don't need to tell me, you know, if you're gonna miss, unless it's more than those 3 days. Okay, programming assignments. You can work in pairs on these if you would like. Okay, and so there's gonna be 11 of them, and 1 grade is gonna be dropped. So, and I encourage you to work together. So I guess the integrity applies for a cross pair. So, you know, if you don't have to, it's not required. Totally fine to submit by yourself. But, you know, if you want to work with somebody, that's fine too. Exams, there's 2 midterms and a final. And again, exams are not cumulative. They'll be taken in class. They will have an in-class portion and a take-home coding portion. So the take-home coding, unlike the homework, is an individual assignment. So you will have to, sort of test setting, you'll have to do that by yourself. Okay? So again, just let me know if you have a conflict with an exam and we can set something up. And then I usually just ask people to set their stuff aside so that don't use devices or anything like that during the exam. Make sure you use the restroom before an exam because you won't be allowed to leave the room. Just things like that, but we'll go over that in greater detail once we get to the exams. Looking at the grade breakdown, so each exam is 20% of your grade. Programming assignments, that's the biggest one alone, are 25%, and then your attendance and participation is 15%. So it really is important to do the daily dish if you can show up and do it. And then programming assignments, also really important. So that's what the breakdown is going to look like. If you have a need for some kind of accommodation, just let me know, get me a letter or something like that, come talk to me. And of course, if you know, you feel like you're being discriminated against in any way, you have access to resources at the Title IX website from the university. Also, so the late work policy is such that basically I need to change the date on this, I apologize. Actually, no, I don't. So the assignment's due on that day. I usually make it like 11:59 p.m. on that day, so kind of the end of the day. If it comes in a day late, it'll be 10% off, and then another 10%, and so on. So yeah, you can still get credit if you submit a little bit late, and I encourage you to do that, but try to get your programming assignments in on time, because they will just creep up on you otherwise. Also, do give the opportunity for grade appeals, so up to 1 week after the assignment's been graded, if you see a discrepancy, then you can come talk to me and we can take a look at it. Okay. If you have any questions on the information in the syllabus, let me know. The schedule, we're planning on moving through the way that it is, but things do change and I will let you know about that if that happens. All right. So, okay, enough administration. Let's talk about automating the boring stuff. So I love the title of this book, Automate the Boring Stuff, because it really gets at what Python programming in this kind of scripting style is about. You have certain tasks that you could do manually, and many people do manually. But if you could write a program that did it for you, then you could not have to do it manually. You could just automate it, let it run, and then walk away and do something, go outside and smell the roses, something like that. So here are some examples. Moving and renaming thousands of files that you might have and sort them into folders. Fill out online forms with no typing. Download files from a website. So this is, where you start to get into applications. We will do some web scraping. If you wanted to get a list of hotels, let's say, in all of Europe, you really didn't know where you were going to go, but for some reason you needed a list of all these hotels with their addresses. You wouldn't want to go to a website that had that and have to go on every single page. You would want a way to get all that information automatically and store it somewhere so that you could process it. So it really goes back to the nature of the way things are right now, that there's so much information available. And because it's connected on the internet, or otherwise, that we have access to it, but we need some tools to help us work with it, to help us process it. That's the goal here. You can also work with, there's a couple other things here. You can make cool things that have your computer send you notifications. You can work with Excel and Python. You can even send emails using Python, which is kind of silly. But it's all about making things faster, automating things that you would otherwise have to do with, by yourself, manually. It's much cooler to do it automatically. Okay. So what is programming? If you've had a programming course, then you have some idea, or maybe you don't, I don't know. But programming, the way I see it, is a combination of data and its use. So data, its storage, all that sort of stuff, and then algorithms. So kind of the data and then the procedures, the algorithms that you use to process the data. So here are some example algorithms. It's the fancy word for series of steps or procedure. So sometimes we have something where we do this and then do that. So this is something as simple as I type in my first name and then I type in my last name. You can think of so many things that you do by yourself, or that you see, processing if you want to buy a movie ticket, that whole process, the way that the system interacts with you. There's algorithms behind there. The way that a coffee maker works in order to make you coffee, it follows a series of steps. Does this, then that. But it's not enough sometimes just to write a procedure that does various things. Sometimes we want it to do things if certain conditions are true or are untrue. So, for example, I have 2 dogs. So I'm constantly waiting. I wait on the dogs, and then sometimes they tell me that they want something. So if my golden retriever brings me a ball, then I perform the action, I take the ball and I throw it. But until she brings me the ball, I'm not actually going to throw the ball. So that's an example of what's called conditional programming. So if something is true, then we do an action, otherwise we do a different action, or we do nothing, either way. So we have do something under condition. We also have do this action that number of times. So, for example, it's a good example. Okay, so for example, I'm doing some online shopping, and I want to buy several different items, and no, that's a bad example. Let me try again. I'll just use a self-checkout example. Okay, so for example, do this action that number of times. If you're with me last semester, we studied what are called loops. If you're completely new, loops are just you have a specific thing, action that you want to take, but you do it several times, either until the number of times that you want is done, or until certain condition happens. So let's see. If you are using a self-checkout system, it has something built in that kind of keeps scanning items, and it goes through the procedure inside internally to catch the weight and make sure that it's not over or under what it's supposed to be, and it will keep running this loop of checking until you tell it that you are ready to pay. So that is an example of a loop. Do this action that number of times. You can also do this action that number of times, so that's doing it a specific number of times. You can also keep doing a certain action until the condition is true. Crap, I gotta do this again. Okay. Do this action that number of times. So for example, let's say I'm told I need to roll the dice 5 times because that's going to determine how many spaces that I move. Just some game where I have to roll the dice a certain number of times. So I roll the dice once, twice, 3 times, 4 times, 5 times, then I'm done. So the condition for me stopping was that I had rolled. After the 5th time, I was done. And that's an example of a loop. So I'm doing the same task and repeating something over and over and over again. So we also have a case of keep doing that until this condition is true. So let's say I don't know how many times I want to roll the dice. I'm going to roll the dice until I reach the end of the board. So I don't know if that's going to be 5 times, 6 times, 2 times, but I just keep rolling the dice and I keep moving my little character, and then eventually I hit the end of the board and then I can stop rolling the dice. So those are the basic programming procedures. Do this, then that. We have if, then, else. We have for loops. Do this a number of times, or do this action until we have a condition that's true. So, and that's the gist of it. But you'll see algorithms everywhere if you haven't already. So you'll be able to think about these types of procedures and start to see them in the things that you do and the things that you work with. So the next question that generally comes up in this type of class is, do I need math? Yes and no. Okay, so no, you're not going to be doing, calculus, differential equations, whatever kind of higher level-ish of math. However, to the extent that, like, take this example of playing Sudoku. There's kind of an algorithm here in terms of solving it, of figuring out what numbers are missing and where to put them, but you don't really need heavy math. It's more about logic. So I can say this, if there's math involved, like you have to calculate a statistic or something, the formula will be given to you. So you do not have to invent any math, you do not have to be a mathematician, you just have to be able to, plug things in where they need to go, sort of like in an accounting class. So no, you don't need any heavy-duty math for this course. Alright, so the next question, why Python? Well, Python, I'll sing its praises a little bit, but it's so versatile, you can do so much with Python, and it really is friendly. So you'll see that, it's just friendly. You don't have to tell it certain things, and it takes care of a lot of things for you, and it just looks friendly. So it doesn't look scary. So what can I do with it? Well, I included this link. This is actually an example of something that's pretty cool. One of the more kind of up and coming things right now is natural language processing. If you can tell an employer that you have experience with natural language processing, that will be a very good thing for you. So I kind of want to get the ball rolling at least a little bit on that. And this link is not loading. Okay, so on this person's page, they explain how to, on their blog, they explain how they built a sentiment analysis tool for Twitter with a Python script. So what is sentiment analysis? Basically, I have some words. The words may be positive, they may be negative, they may be neutral, and I want the computer to be able to tell me if it's mostly positive, mostly negative, mostly neutral. And you can kind of do different variations on that. But basically, this person used the Twitter API to do this. And they have a little GIF of how they worked through it, even to the point where, so they used the API to access all these tweets about Tesla. And they were able to throw them into Excel. They were then able to write Python script to analyze all these tweets. So you can see here, what subject do you want to analyze? Tesla. How many tweets? 50. A CSV file in Excel is created, and 50 tweets are analyzed. And then once this is done, actually a nice visualization is created of saying how many were positive and how many were negative. So again, this is a case of automating something that could have been very boring. You would have had to have gone to Twitter or done a search for tweets about Tesla from various outlets, and then have to gone through them manually and decide also which were positive words, which were negative words, and it would have taken you a really long time thinking about doing that. But this made it so fast to get this information. Okay, and so there's other stuff. There's just a lot of cool stuff that you can do with it. Okay, the next thing you should be aware of is that you will get errors. You will get errors. I get errors. People a lot smarter than me get errors. Everybody gets errors. It's just life. So I like this comic a lot because it shows the frustration, but I'm telling you that you can get through it. So that's one of the big things that I'm about, is that, you know, you're going to run into this stuff, and that's just kind of part of it. There shouldn't be this feeling that, you know, it's better than you are, or that once you hit a wall, like, you won't be able to do it. The important thing about programming is to just keep trying things. That's how you learn from it. It's one of those things that you really do learn by doing, rather than kind of memorizing information. You get a lot of implicit knowledge just by working with Eclipse, in this case, and seeing what happens. You start to internalize the things, so you're like, well, if I do this, this is going to happen. If I do this, this is going to happen, and this will be good, or this will be bad. You start to kind of make a mental catalog of how it's working. So here's an example of how we can work it out, in the words of the Beatles. So this is a run in the Python shell, which we won't be using, but something that could happen to you. Here's what it spit out. 42 in single quotes plus 3. Trace back, most recent call last. And then we have type error, can't convert int object to stir implicitly. Okay. So if you have no idea what this is, even what any of these words mean, let's say you don't know what any of this means, doesn't matter. All you need to do is that you hope that somebody else has run into the same problem. Okay? You're not expected to see this, that's the whole point. You're not expected to know what the error is. What you should do is copy copy it, can't convert int, so specifically the error, can't convert int object to string implicitly. Take it to your web browser and do a search. Here are the results for this search. Type error, can't convert int object to str implicitly. There are several options here, and these top ones are all from Stack Overflow, but there's also one at the bottom from the Python forum. If you click on these, you should read them, okay? Kind of figure out what is going on, and it's very likely that someone has suggested a solution. So if you're stuck or you get an error especially, I highly encourage you to do this process. Just look it up. Hopefully someone else has experienced the same thing. If you don't find anything, bring it in. I'll see if I can do it, but I'll tell you, I'm just going to do the same thing. I'm going to go online and I'm going to look to see if someone's resolved the error. Okay. All right. I said it was cheesy. This is cheesy, but it's very true. Okay. So if you want to be successful in my class, come to class, because Daily Dish is 15%. It's a lot. Once you get your programming assignment, don't shy away from it, okay? And if you're working with someone, you should badger the other person to kind of get on it as early as you possibly can. This will ensure that you have enough time to work through all of the errors that we just described, because they will happen. So it's not the sort of thing where you're just going to start it and work beautifully from start to finish. I shouldn't say never. I mean, that does happen, especially if you have a lot of experience. But for the most part, you will hit one or two little things. The other thing I would recommend is make those mistakes. Just make them. And, don't feel like you're a bad person or something. That's really not an issue. It's just something that happened. So just let it kind of happen to you. Note that it happened, and then, get up and try it again. The other thing I want to stress is, I don't know, I'm new to San Antonio. I've noticed that there's a lot of, I don't know if it's fear of asking questions. I'm not really sure what it is, but ask questions. It's okay. The assumption is you're here to learn, so you probably don't know, and that's okay. But you're not going to know unless you actually ask the question. And I know people say this all the time, or maybe they do, maybe they don't, but I really do mean it, to ask the question. And yes, there shouldn't be any pride involved. So we want to get to the bottom of it so that you make those connections. It's all about the learning process. Okay, so making sure that you know what you need to know. Try stuff is the other thing. Just try stuff. So many times students will come and they say, well, what happens if I do this? Well, frankly, sometimes I know, sometimes I don't know. But the beauty of it is, if you have Eclipse, you can try it. You can try it. And you can actually see what happens. And then the last one, reason through your failures and your successes. So there's some kind of joke in here about engineers versus mathematicians, and each group build a bridge and one of it falls down and they know why. The other group falls down and they have no idea why, or it stands and the same thing happens. Anyway, it's important to understand why something you didn't work, so that you can know not to do it in the future and or help someone else. But it's also important to know why something worked. I know sometimes it's tempting just to have it work and then kind of move on from it, but you're more likely to be able to use that knowledge later if you reason through why it worked. So that's kind of what I would prescribe to be successful in my class. The other thing I wanted to share with you was I've been getting into something called the growth mindset. So there is a lot of research in this area, more so in elementary school, junior high, and high school, but I don't know why they don't apply it to undergraduate education or even graduate level education. Basically, the growth mindset, to sum it up, is there's this assumption, especially in math education, that students have a set point for their math intelligence or their math skill. Now, this isn't math, but the same thing applies here. I'm here to tell you from experience that I've seen that this is not the case, unless you believe it to be true. So, in other words, there's no set point. We have the ability to grow. And it's only through pushing through the issues that you have, whether, it's in your life or whether it's in programming or in writing, whatever it is. If you push through it and you can get to the other side, you can then look at things from a different perspective, and you've learned a whole lot. And now you've kind of raised your set point, basically. So there's no kind of, there's definitely a lot of factors that play into it. But if you look at this diagram, basically it's the idea that you can get smarter, for lack of a better way of putting it. This thought really drives motivation and achievement, even in young students. So if they think they can do it, then they say, well, learning's my goal and effort makes me stronger. They see that the results come once they work. Then they decide to spend more time working on it. It's harder. It's kind of like sort of fake it till you make it a little bit too. The more effort you put into something, by default, generally, you're going to do better at it. And all these things lead to higher achievement. But the thing that it starts with is just saying that you can do it. And so that's one of my roles as your teacher, and one of my goals as a professor is to instill that in the students that I meet. So that doesn't matter where you're starting from, basically. There is always room for growth, and you can achieve that growth if you just kind of put your fears aside and you just jump in and you just try it. So case in point, I'll just get this off my chest now. I was an English major as my undergrad, and there are various things in my life that happened. I decided to get a PhD in MIS, and I've loved it ever since. It's been really interesting. But when I entered the computer science classes that I had, I wasn't sure if I had, what it took to kind of do it. But once I started diving into it and saying, no, I believe I can, then things really started to work out for me. So just start trying. That's what I'll say about that. So to go along with that, here's the results from another study. Basically, students, there were two groups of students, and they were doing, again, math problems. So what they measured was how many problems the students did in the first trial, then the students had a failure, and then how many students did in their last trial, or how many problems they attempted, how many they solved. So, but in the middle, after they did a first set of problems, the green group, the students had the amount of effort they put in praised. So the comments were, great job, you really put in a lot of effort, you really worked hard on this. The students in the orange group instead were praised on their intelligence. So it would either have been, oh, you're so smart, or you're so stupid, comments like that. And if you look, the total number of problems solved in each group, it definitely went up in those that were praised on their effort rather than on their intelligence. So again, the idea here is that if you believe that you can work through it, then you will. You'll put in the effort, you get rewarded for your effort, and then it will help you achieve even more. So if you want to check out more on this, let me see if I can put this. There's a great book. Her name is, not the book, but Jo Boaler. She has a book called The Mathematical Mindset. If I can spell correctly, The Mathematical Mindset. Great book. So again, it's kind of geared toward younger students, but the same thing applies. Same thing applies. All right, so enough waxing philosophical. This would be the point in class where I give you the opportunity to work on the daily dish. So I need to change this number. I should say 28 and 25. Okay, so if we open this link up. Yes, okay. go through and get these done before next class. So I know we weren't physically in class, but we're going to count this as class. Please get this done. Again, you have 3 excused absences. They typically will only be 1 or 2 things, but since this is the first class and I had a couple other things I threw in here, I wanted to do a couple more. Put your first name, your last name, so that I can give you credit for it, and then go ahead and answer the prompts. Okay? So take time to do that, and I will look at those. For Thursday, I think we will meet Thursday. I know tomorrow we're going to have a late start. I'm posting a link to the software guide, so try to get that done. And then take a look at Automate the Boring Stuff, Chapter 1. So that's what we'll be working on Thursday. So again, extra credit, you can email me. Where is it? You can email me here. Get the software installed if you can. And I'm really looking forward to this class. I think that it's going to be a lot of fun. It'll be a little difficult, I'm sure, but I think it'll be a good class. So I'm really looking forward to meeting you all, and I really hope to see you on Thursday. So stay safe, stay warm, and I'll see you in class.